Alright, this is going to be our first video from chapter 16, and it's actually quite a sizable chapter. There's a bunch of stuff to talk about. The first thing to note here is the chapter is dealing with carboxylic acid derivatives, so molecules that are made from, or that essentially are derived from carboxylic acids. And there are several examples. Alright, acid chlorides you've seen before, anhydrides, also known as acid anhydrides, you probably haven't seen before. Amides, well, you've seen those before. Esters, you've seen a little bit before, but not too much. And then acyl phosphates you won't have seen before. There is actually a sixth class called thioesters in the book, which I'm not going to focus on. So let's look at the word derivative and see what that means with respect to these molecules. We've seen before that an acid, a carboxylic acid, looks like this. Alright? With whatever this group is here, some R group. So when we talk about derivatives of that, all we're talking about is taking this group and replacing it with something else. So for an acid chloride, as you can probably imagine, that group has changed from OH to Cl. For an anhydride, that group, and tell you what, I will underline that so you know which. In fact, I'll put a circle around this so you know exactly which bit we're talking about. An anhydride replaces that whole OH with a group that looks like this. So this is also almost symmetrical. In fact, if these two R groups are symmetrical, that would be called an asymmetrical anhydride. So I'm putting the red box around the pieces that signify the different functional groups that are different from the original OH. Alright. Now you guys have seen amides before. You know what the group is going to be coming off the carbonyl here, because you just saw it on the previous video. It's an NH2. There's your amide. So we'll put the box around there. There is also the ester. This is a little bit different again. It's kind of like the acid, except there is a carbon group on the oxygen rather than a hydrogen. That has important ramifications. We'll focus quite a bit on that later on. And then the last one, in some ways the most biological relevant of these, apart from the amides, are the phosphates. Okay, well, what I have is a group that looks something like this. Phosphate is PO4 3-, so a phosphate group like this would look something like this. You'll see a whole bunch of these in your DNA chains and a lot of proteins and things like that. So these are the 5 groups that are derivatives of carboxylic acids. You'll find that this, and this all follow essentially exactly the same naming convention that we've seen before. The only one that doesn't, that strays a little bit, is the ester. And the main reason for that is the 2 carbon chains here that make naming a little bit more complex. Alright? But this video right now is going to focus on naming conventions for each of these 5 functional groups. Alright, so let's start off with one of the easier ones, the acid chloride. So we'll move on to a new page. So let me just draw out something like this. Let's start off with a guy like this. Alright. Now the key here is, can you name this, and this applies to most of these functional group derivatives, can you name what this would be if it were a carboxylic acid? Alright, so can you name what a 4-carbon carboxylic acid would be? Well, hopefully you can, and you'll be able to say, well, that is butanoic acid. Alright. Now, when you go from this to your acid chloride, we have to make a little bit of a change. Alright. And what actually changes here is This isn't an acid anymore, so we're going to get rid of this. And we get rid of the last two letters here. So we get rid of the ic acid. So everything else stays just as it was, essentially butanol. Alright. Let's see. Now this should probably be the oic acid that we're going to take off here. And we're going to replace this with oil, OYL, and then simply the name of whatever this leaving group is. And in the vast majority of cases it's a chloride. If it was a bromine, it'd be bromide, and so on. So we take away the word acid, get rid of oic to signify carboxylic acid, and stick oil on the end, and then the name of whatever the leaving group is. Butanoyl chloride. It sounds a little odd. Some of you may have heard of something similar before. If anybody has heard of this, benzoyl peroxide, it's acne medication and used for a few other things too. Oil has essentially the same meaning as it does here. Alright, but anyway, that's off topic a little bit. Let's just look at one example of that. In fact, let's look at 16.1a. Alright, I'm just going to draw this out. So we have this, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So coming off that fifth carbon is the carbonyl and the chlorine. Alright. So the longest carbon chain here will be 5 carbons, so pentane. Alright. If that was a 5 carbon acid, it will be pentanoic acid. Lop off the oic acid and stick oil chloride, so this becomes pentanoyl chloride. But there's a methyl group on carbon 4, so this would then become 4-methyl pentanoyl chloride. Right. What about if we had a cyclic one? What if we had this? Let's have a 5-membered ring with this coming off here. The trick, as we said before, was can you name this as the corresponding carboxylic acid first, because that's a good place to start. Alright, let's see if we can remember how we name this. What's the name of a carboxylic acid with a 5-membered ring as the parent chain or parent ring? Well, if you remember, you take the name of the ring, in this case cyclopentane, and then what do you add on the end? Well, you add on the words, 2 words, carboxylic acid. So that's simply cyclopentane carboxylic acid. Now, for molecules like that, all we do is we take off the word acid, we actually take off the whole of the word carboxylic, and we replace it with the word carbonyl. So what happens is here then we get, it's still cyclopentane, cyclopentane, and then the naming convention tells us, I'm writing this just underneath because I think I'd run out of space otherwise, cyclopentane, carbonyl, and what would come at the end? Well, you haven't got your chlorine there, your chloride. So therefore, cyclopentane carbonyl chloride. And that's it. Alright, so remember, always start from the corresponding carboxylic acid and then work backwards from there. Alright, so that is carboxylic acid. So that's acid chlorides. Let's move on to anhydrides, and these are actually, they can be even easier. So let me draw out one example. In fact, that doesn't look good. The anhydride functional group looks like this. An oxygen in the middle, 2 carbonyls coming off each side of the oxygen. Alright, and then you're going to have whatever coming off, whatever R group coming off either side there. And you can have 2 situations for anhydrides like this. You can have ones like this that are symmetrical, or you can have those that are unsymmetrical. So let's do an example of each. Both of them have the anhydride central functional group. And let me put a benzene here. And then let's just do this. Alright? So let's start off with the first one. These are the ones that are the easiest to name. Again, start off from the name of the carboxylic acid that this comes from. So 5 carbons. You know, a 5 carbon acid would be, we saw this just earlier on, pentanoic acid. Alright. And then simply, if this is an anhydride, simply all you do is take out the word acid and replace it with the word anhydride. So you might wonder, well, don't I need di for the fact there are 2 of these pentanoic carbons, pentanoic chains? Well, the term, simply the use of the term anhydride implies you understand there are 2 of them. 1 carbon chain here, 1 carbon chain here. So there's no need for di or anything. Pentanoic anhydride means an anhydride group with 5 carbons coming off the central oxygen in each case. You always want to count the carbonyl carbon here. 1, 2, 3, 4, 5. And it's exactly the same the other way. 1, 2, 3, 4, 5. Alright? That's for symmetrical anhydrides. Unsymmetrical, the suffix is exactly the same. It's still anhydride, so let's put that right here. Anhydride. Now, what do you think we would do then for an unsymmetrical anhydride? How do we name things? Well, it's exactly the same way it's been named before. You just name them alphabetically. Okay. All you need is the corresponding names of the acids that you started from. So, if you can say, for example, what acid this is derived from, just as you did here, you had 5 carbons here. You start off with pentanoic acid. You would start off here with benzoic acid. And so the word you take there is benzoic. And then over here, 3 carbons, propanoic acid. The word you take here is propanoic. And I hope you can tell how you arrange those. It's just alphabetically. So therefore, benzoic, propanoic, anhydride. Alright? Just arranged alphabetically, and there you go. Alright. Next one. Amides. Potentially quite simple too. So let's take a look at those. Let's do a nice simple amide here. Amide containing 4 carbons. Alright. The suffix for an amide is simply that, amide. And all we're going to say is, okay, 4 carbons based on butane. Do we need to lop off the last E? Well, yes we do, because amide starts with an A. So this becomes butanamide. Simply that. Alright. So if I was to do something like, well, let's try something a little bit more involved. Let's do this. it's not really that much more involved, but you can see where we're going here. Yeah, let's try this. Longest carbon chain is 4 carbons, just as it was here, so that's butanamide. But you can also see we have a methyl on carbon 2 and 2 methyls on carbon 3. So therefore 2,3,3 trimethyl butanamide. All right. The only thing that would make these potentially more complex, as is the case for carboxylic acids, is when you have one that's cyclic. All right. So what if we had this? Well, how would we name this if it was a carboxylic acid? Well, it would be cyclohexane carboxylic acid. And the only thing we have to remember here is what that suffix changes to if this is an amide. All right. For aldehydes, if you remember, aldehydes coming off a ring, it was a carbaldehyde. For carbonyls, it was carbonitrile. For carboxylic acids, it was just carboxylic acid. And for amides, it turns out that the suffix is carboxamide. Carboxamide. So in this case then, the name of this would simply be cyclohexane carboxamide. All right? And that's essentially amides. Now, the only thing that might make amides a little more complex, so let's just do one of these before we move on, is what if we had this? So we have what looks to be a regular old, in this case 1, 2, 3, 4, 5, 6 carbon amide. But what if I gave you this? Now you got what looks to be 2 carbon chains. In fact, let's make it a little bit more interesting. And let's put 2 carbons here. Make you really wonder, well, what do I do? Okay. Well, the carbon coming off the carbonyl here is always going to be the parent chain, always, always, always. So you're still going to count that as the longest carbon chain. So if that ethyl group wasn't on the nitrogen, it would just be hexenamide. But we have to take this into account too. And as you've seen before, every time we have a substituent, we need a location for it. So if there was an ethyl group on 2, it'd be 2-ethyl, 3, it'd be 3-ethyl, 4, it'd be 4-ethyl, and so on and so on. But because the carbons start here, we can't really give the nitrogen a number, but the nitrogen is the location of the ethyl group. So instead of giving it a number, we haven't done this before, this is something new, we simply use the location of the nitrogen and say it's N. Because if we say N, for example, if we say N-ethyl, then we understand that means there's an ethyl group on carbon N. There's an ethyl group on the nitrogen. And then you just fill the rest of the name in. N-ethyl hexenamide. And if we had 2 ethyl groups coming off here, we treat it just as if we would treat 2 ethyl groups coming off carbon 3. We wouldn't say 3-diethyl, we'd say 3,3-diethyl. So therefore, if there's 2 ethyl groups coming off N, you want to mention N twice. In other words, this, if these are methyl groups, this would actually be N, N, dimethyl, in this case butanamide. Notice I'm treating the N's here like numbers. Comma between them, if there's more than one, hyphen between the N and the start of the name. So you just treat them just like numbers. And that's essentially it. Alright? Okay. Last thing here, because we may not get too focused much on phosphates, but that's not a big deal. I want to spend some time on esters because these can be potentially complex. Potentially. They're really not that bad, but they certainly can cause a lot of unnecessary confusion if you're not told the best way to go about naming them. All right? So let me see what I can do to sort you guys out and prevent any problems from happening before they happen. All right? Okay. Esters. When naming esters, the first simple rule is to remember there are 2 carbon chains, so you have to know where each one comes. An ester is made up essentially of 2 parts. You have the part that looks like it comes from an alcohol, which is the carbon group that's connected to the singly bonded oxygen. So we'll call this the alcohol part. It's not really the alcohol, or it's not really an alcohol, but it looks somewhat similar to an alcohol, so we'll call it the alcohol part. Right? And then we also have what we'll call the acid part, where there's the carbonyl group. Right? So this is the acid part. Okay, like so. And as far as esters go, the first thing you always do is to name the alcohol part first. And the way you name that alcohol part is you simply take the number of carbons and name it as a substituent. A 4-carbon substituent we know is butyl, so therefore that's how we would name that. A 3-carbon substituent would be propyl, but this propyl is connected in the middle, so that's just not propyl, that's isopropyl. So we're naming it even as if there isn't an oxygen there, we're just naming the carbon portion of the chain here. And then to name the rest of it, to name the acid part, we first name it as if it was a carboxylic acid. Okay, so let's look at this bottom one here. The carboxylic acid that this most resembles is benzoic acid. Benzoic acid. Alright? And then all you do is you replace the oic acid with a different suffix to represent an ester, and that suffix happens to be oate. So what that means is benzoic acid turns into benzoate. Isopropyl benzoate. So remember, alcohol part first, acid part second, and it's the acid part that gets the ester part of the name. The alcohol part is just named essentially as a substituent. It's not any less important, it's just the way the naming of esters works. So let's go back up to this guy. 2-carbon acid would be acetic acid, alright, or I should say ethanoic acid, let's just say that. Let's use our naming convention, ethanoic acid. So we lop off the oic acid and put oate on there, we get butyl. Ethan, we've lopped off the oic acid, we're going to stick oate on there. Butyl ethanoate. And that's how you name esters. Now let's just go through, let's just look at an example. Let me just come up with one more here before we go, because it's way too late and I have to get to Betty Buys. Alright, okay, so let's draw out this. Let's go ahead and try this one. And so we have this. Well, actually, yeah, let's keep it a little bit more simple for now. Let's just do this. Let me put this back here. Okay, now remember what we said before. There's the alcohol part and the acid part. The ester can be drawn more than one way. Here I have the alcohol part on the right. Here the alcohol part is on the left. So always make sure that you separate your alcohol and your acid parts before you do anything else, so you know exactly what's coming first. This is the alcohol part, so we're going to name it just as if this were a substituent by itself. And so what's the name of a 5-carbon substituent? Well, it's pentyl, but it's in a ring, so it becomes cyclopentyl. Alright? And then the acid part, how many carbons here in this acid? Well, it would be 3, which would mean propanoic acid. We're going to lop off the oic acid and stick O8 on the end. Cyclopentyl propanoate. Alright. And there you go. And that is naming esters. I'm going to leave phosphates until later, or maybe not at all. Like I said, I'm tired. So, go to bed. Unless you're watching this early in the morning. But I'm going to bed, and I'm rambling, so okay, bye.